Hi, welcome back. This is Professor H. Today's lesson is on section 6.5, inverses of matrices. For any positive integer n, the n by n identity matrix is an n by n matrix with ones on the main diagonal and 0 everywhere else. And it's denoted by this I equals, and then again the main diagonal is the position, row 1, column 1, row 2, column 2, so on. So you got ones in all those places and then 0 everywhere else. Okay, so that's the identity matrix. And it has to be a square matrix, 5 by 5, 2 by 2, 3 by 3, whatever. Okay, so the rows and columns have to match. And just like in multiplying with 1 in real numbers, 1 times any number is that number. Well, same thing, and that's called the identity. So here we're generalizing the identity for a matrix. Any A times I equals I times A, which equals A, for any n by n matrix A. So basically anything times the identity is going to be itself. That's the idea. Okay, so let's just look at it. If I take A times I, now from what I just wrote down above, it should be, the result should be A. So let's look at it. And remember, you're going to take the row times the column, row times the column. So we're going to get 4 times 1 plus negative 5 times 0. And then row times column, row 1, column 2, 4 times 0 times negative 5 times 1. And now we're going to go to row 2, column 1, so 3 times 1 plus 2 times 0. Then row 2, column 2, 3 times 0 plus 2 times 1. And we get 4 plus 0 is 4. Now 4 times 0 is 0 plus negative 5. And then we get 3 plus 0, which is 3. And 0 plus 2 is 2, which you can see that's A. Alright? And if you did it the other way around, you get the same result. And remember, matrix multiplication is not commutative, so generally you don't get the same answer when you switch the order. But for the identity, it doesn't matter, right? Anything times the identity is 1. The identity times, anything times the identity, it's itself. And the other way around, it's the same thing. The identity times A should get us A. So let's just check. Just wants to make sure. Okay, so we're going to get, remember we're going to do row times column. So 1 times 4 plus 0 times 3. Then row, column. Negative 5 times 1 plus 0 times 2. Then we're going to go row 2, column 1. So there'll be 0 times 4 plus 1 times 3. 0 times negative 5 plus 1 times 2. And you get 4, negative 5, 3, 2, which is A. Okay, so you can see that anything times the identity is going to be itself. And that's the identity property. Okay, so the next thing is we want to know, how do you find the inverse of a matrix? How do you get back to the identity by multiplying? So an n by n matrix A, if there is a matrix A inverse, for which A inverse times A equals I, which equals A times A inverse, then A inverse is the inverse of A. So this A to the negative 1 power, we read it as, just the way I just did it, read as A inverse, which means the inverse of A. Okay. Okay, so if I want to verify that B is the inverse of A, what we need to do is we need to verify that B times A equals I, and that A times B equals I. Okay, so we're going to check that. So both has to work. So we're going to do B times A, which is 3, negative 2, negative 4, 3, times 3, 2, 4, 3. And remember, you're going to do row, column. So that's going to give us 9 minus 8, row, column, be 6 minus 6. Then we're going to go row 2, column 1, so that's going to be negative 12 plus 12. Row 2, column 2 would be negative 8 plus 9. And that gives you 1, 0, 0, 1. So that part's done. Now we got to check, which is I. And then we got to check the other way around. A times B. So 3, 2, 4, 3 times 3, negative 2, negative 4, 3. And again, we're going to do row, column. So that's going to be 9 minus 8. Row, column, be negative 6 plus 6. Now row 2, column 1, be 12 minus 12. Row 2, column 2 would be negative 8 plus 9. And we get 1, 0, 0, 1 again, so which is I. So yes, B is the inverse. B equals A inverse. Okay, so now the question is, how do you find the inverse if you're given an example? So basically, to find the inverse, okay, so to find the inverse of a square matrix, you're going to use row operations on the following augmented matrix. So you're going to put your matrix that you start with, and your goal is to get the flip-flop it, and you're going to get the identity matrix on the left, and then what's going to be on the right will be the inverse matrix. Okay, so you start out with the matrix you're looking for the inverse on the left, and then you augment it with the identity matrix. And you do the row operations to transform it into I on the left, and then A inverse will be what's on the right. All right, so let's try one of these examples. All right, let's try find A inverse if it exists. So note, if you get a row of zeros on the bottom, on the left side, and then you get numbers on the right side, of course, you get a contradiction, so that one would not exist. So example, if you had, okay, I'll show you later. All right, so first, what we're going to do is you're going to start out, you want A, I, so you're going to write it 3, 5, 1, 2, and then we're going to do this identity matrix with the same order, so 2 by 2. And our focus is on the left side. We want to transform it into I, and then the right side would be A inverse. Okay? So we're going to do row operations, and we'll do the Gauss-Jordan method. So we're going to switch row 1 and row 2, because I want a 1 there first. So 1, 2, 0, 1, 3, 5, 1, 0. So I just switched row 1 and row 2. Now I want a 0 where the 3 is. I want a 0 here. So I'm going to leave row 1 alone. New row 1. And I'm going to take negative 3 times row 1 and add it to row 2. So just like we did with the elimination method, same technique. So that's going to get us 0. Negative 6 plus 5 is negative 1. 0 plus 1 is 1. Negative 3 plus 0 is negative 3. Now I want a 1 where the negative 1 is, so I'm going to leave row 1 alone. 1, 2, 0, 1. And I'm going to do negative 1 times row 2. And I'm going to get 0, 1, negative 1, 3. Now I want to get a 0 where the 2 is, right there. So I'm going to take negative 2 row 2 plus row 1. And again, I'm referring to the matrices that I just did when I write this. So negative 2 times 0 plus 1 is 1. Negative 2 times 1 plus 1 is 0. Negative 2 times negative 1 is 2 plus the 0. Negative 2 times 3 is negative 6 plus 1, negative 5. And we're going to leave row 2 alone, and now we're done. So A inverse is equal to 2, negative 5, negative 1, 3. And then you can check it. You can multiply A times A inverse and see that you get the identity. I'm not going to check it. Alright. So now let's try a harder one. Let's try a 3 by 3. Okay, so we got 1, 2, 3, 2, negative 1, negative 2, negative 1, 3, 3. So it's a 3 by 3. So we're going to start with our augmented matrix, a 3 by 3. 1, 2, negative 1, 2, negative 1, 3, 3, 2, oh that's negative 2, 3. Augment it with the identity, 3 by 3, 0, 1, 0. So it's 1 across the main diagonal and 0 everywhere else. And we want to flip-flop this so we get the identity on the left, and then A inverse would be on the right. And we're going to use row operations. Alright, we want a 1 here, which it is, so that's done. Now I'm going to get zeros below it. So I'm going to take negative 2 row 1 plus row 2 and negative 1 row 1 plus row 3. And we leave row 1 alone. 1, 2, 3, 1, 0, 0. Row 2 is going to be 0. Negative 4 minus 1 is negative 5. Negative 6 minus 2 is negative 8. Negative 2, 1, 0. And then we're going to do row 1 plus row 3. 0, 5, 6, 1, 0, 1. Okay. Now I want to get a 1 in the middle here. So I'm going to divide that by 5. So I'm going to leave row 1 and row 3 alone. 1, 2, 3, 1, 0, 0, 0, 5, 6, 1, 0, 1. I'm going to divide this by negative 5. So negative 1/5 row 2. So it'll be 0, 1, 8/5, 2/5, 1/5, 0. Okay, now I want to get my zeros, so I'm going to go negative 2 row 2 plus row 1 And then get the bottom one, negative 5 row 2 plus row 3. Row 2 is going to stay the same. Okay, so we're going to go negative 2 times row 1 plus, row 2 plus row 1. So that's 0, 0. Negative 16 fifths plus 3 is negative 1 fifth. Negative 4 fifths plus 1, that's 1 fifth. Negative 2 fifths plus 0 is negative 2 fifths. And 0 plus 0 is 0. Okay, now we're going to do negative 5 times row 2 plus row 3. So that's 0. Oh, I messed up. This should have been a 1. Right. Negative 2 times 0 plus row 1 is a 1. So that's 1. Okay, now row 3. Okay, negative 5 times row 2, which is 0, plus 3 is 0. Negative 5 plus 5 is 0. Sorry, let me start over. Negative 5 row 2 plus row 3. So I'm going to go negative 5 times 0 plus 0 is 0, and write the 0 down. Negative 5 times the 1, which is negative 5, plus the 5 gets me 0. Negative 5 times 8 fifths is negative 8, plus the 6 is negative 2. Negative 5 times 2 fifths is negative 2, plus the 1 is negative 1. Negative 5 times 1 fifth is negative 1, plus the 0 is negative 1. And then negative 5 times 0 is 0, plus the 1 is 1. Now I'm going to divide row, I want to get the 1 in this spot, so I'm going to divide row 3 by negative 2, which is negative 1/2 row 3. Did I say row 2? It's row 3. 1, 1/2, 1/2, negative 1/2. And then we're going to leave the other 2 rows alone for this step. And now we want to get a 0 above in the third column above the 1s. So I'm going to go negative 8 fifths, row 3 plus row 2, and then I'm going to do 1/5 row 3 plus row 1. And row 3 is done. 0, 0, 1, 1/2, 1/2, negative 1/2. Okay, so now we just got to do the math for these columns. So I'm going to get, let's do the top row. 0 plus 1 is 1. 0 plus 0. 1/5 plus negative 1/5 is 0. Now the hard part here. So 1/5 times 1/2 is 1/10 plus 1/5. 1/10 plus 1/5, that's 3/10. And then we'll move to the next column. 1/5 times 1/2 is 1/10 minus 4/5 or 2/5. Checking my work, I noticed that I have a negative error right here. Negative 1/5 times 1 is negative 1/5. So let me make sure, fix that. Okay, and then that mistake, if I relook at this one, negative 2 times row 2, I have to fix there. So negative 2 times the negative 1/5 is positive 2/5 plus a 0. So that should be a positive 2/5. Okay. And then that was the only place. So again, that's why it's important to write the notation. So that's a good example of, I made a mistake. I can go back and see, okay, what did I do? And it's easier for me to find the mistake instead of me having to start over. Okay, so let's move on. 1/5 row 3 plus row 1. So where was I? So 1/5 times 1/2 is 1/10 plus the 2/5 is going to get me, hang on, again I forgot that negative sign. Everywhere where I have that row 2 error I got to check. So negative 5 times row 2 plus row 3, and I'm going to get positive 1. This should be a positive 1. So then this will become negative 1/2. Alright, now I'm ready to go. Okay, so 1/5 row 3. So sometimes, you almost just got to start over, but I was able to fix it. So again, that's the importance of writing the notation down so you can see what you're doing. 1/5 row 3 plus row 1. It's going to be 1/5 times 0 plus 1. 0 plus 0. 1/5 plus negative 1/5 is 0. And then 1/5 times 1/2 plus 1 is 3/10. 1/5 times 1/2, this one's negative 1/2. So that's negative 1/10 plus 4/10, which is 3/10. And then negative 1/2 times, that's negative 1/10 plus 0 is negative 1/10. Alright, and then the middle row, row 2, we get negative 8/5 row, so 0 plus 0, 0 plus 1, negative 8/5 plus 8/5 is 0, negative, negative 8/10 plus 2/5 is negative 8/10. Okay, that's negative 4/10. And then let's see, we're going to get 4/5, positive 4/5 plus negative 1/5. Wait a minute, is that right? So we're going to get negative, so 8/5. So it'll be 4/5 and then negative 1/5. Well, I should write this one down with the fractions to get me. So let's see, negative 8/5 times negative 1/2, that is positive 4/5, plus the negative 1/5 is 3/5. Oh, sorry, we had a brain freeze there. Alright, so 3/5. And then the last one, I'm going to go negative 8/5 times negative 1/2 is 4/5 again, plus 0. Okay, that one's easy, is 4/5. Alright, so A inverse is equal to 3/10. And if you want, you can factor out 1/10 and write it out in front, and then you can have whole numbers here. You factor out the LCD, but we can leave it this way too. 3/5, 4/5, 1/2, negative 1/2, negative 1/2. Alright, So that's my answer there, and I can check it. If I do A times A inverse, I should get the identity matrix. All right. So hopefully I didn't confuse you too much with those couple mistakes. But again, I kind of like showing you when I make a mistake, because then you can, understand why I say, hey, you need to write down the notation that I use. So if you do make a mistake, it's easier to go back and see, okay, what did I do? How did I get that? Oh yeah, that was a mistake. That should have been negative. And then you can make your appropriate changes, and it's not completely lost. Okay, sometimes you make such a bad mistake, you just scratch it all out and start over and try again. And that's what I do a lot of times too. All right, but again, I kind of like showing you when I make mistakes, just to show you, hey, it happens. You deal with it, you move forward. All right, now on to the next thing. Okay, so the nice thing about finding an inverse matrix, it makes solving a system of equations easy, relatively easy. So provided you can find the inverse. Now, not all matrices have inverses, but if they do, you can solve a matrix equation by multiplying on the left side of both sides of the equation by A inverse. So A inverse, so note, if you had AX equals B, and if you multiply by A inverse A on the left side of each expression, A inverse times A is just the identity, and the identity times anything is itself. And then you just get A inverse B. Okay, so we just cut to the chase. Alright, so let's use this. So the two matrices we just found, let me make up a problem. So if we did 3x plus 5, y, and 1x plus 2y. Okay, from the end of the last section, we learned that we can write this as 3, 5, 1, 2, then our variable matrix, x, y, equals our constant matrix. So this is A, this is B, not B, this is X equals B. So X, which is our variable matrix, is going to be A inverse B. So if we can find the inverse of A, now this is the, A happens to be the matrix that we did in the last example. We know that we just worked it out. A inverse is going to be equal to, let me look on my other page here, 2, negative 5, negative 1, 3. 2, negative 5, 1, negative 3. Double check that. Yep. So to solve this matrix, then X is going to be equal to B times A inverse. Oh, I did it backwards. It's A inverse times B. So it's important that you do it the right order. So it's going to be X is going to be equal to A inverse 2, negative 5, 1, negative 3, and B is negative 1, 0. So X is equal to, remember, row, column. It's going to be negative 2 plus 0, and row, column will be negative 1 plus 0. So my answer is negative 2, negative 1. That's not the right answer because I copied the A inverse down wrong. Okay, so that should be negative positive. So it's going to be negative 1 times negative 1 is 1. Okay, so my answer is X equals negative 2, 1. Alright. So provided you have the inverse, this is a pretty easy method. If you don't have the inverse, it takes a little bit of work to find the inverse. There's some good technology out there that you can plug in the matrix and push a button and it tells you what the inverse matrix is. But of course you won't be allowed to use that on the test, so you need to be able to do a couple by hand at least. And then after that, again, I would use technology personally. Alright, let me try one more. Since we did all the work for B, let's try one of those. Okay, so we're going to do AX equals B. So we're going to write it like this. 1, 2, negative 1, 2, negative 1, 3, 3, negative 2, 3. A variable matrix x, y, z equals the constant matrix 7, 3, 0. And to solve it, x is going to be A inverse B. And we just figured out A inverse, the one that I kind of messed up on, but I recovered nicely, hopefully. You're going to get x, y, z is going to be equal to A inverse, which was the 3/10. We'll write it as decimal because it's easier. 3/10, 0.3, 0.3, negative 0.1, negative 0.4, 3/5 is 0.6, 4/5 is 0.8, 1/2 is 0.5, negative 0.5, and negative 0.5. And then times 7, 3, 0, because now I'm just going to use my calculator. So that's going to get me, remember, you're going to do row times column. So it's going to be, I'm just going to punch in my calculator, 0.3 times 7 plus 0.3 times 3 and plus 0 times 0.1, negative 0.1, which is 0, so I didn't even punch it in. And I get, I'm going to get 3. So I'll show you. 0.3 times 7 plus 0.3 times 3 plus negative 0.1 times 0. Negative 0.4 times 7 plus 0.6 times 3 plus 0.8 times 0. And then the last one, 0.5 times 7 plus negative 0.5 times 3 plus negative 0.5 times 0. Punch that in my calculator and I get 3. We do the next one, 0.4 negative times 7 plus 0.6 times 3. I get negative 1. And then the last one, 0.5 times 7 minus 0.5 times 3 plus 0 is 2. And see, and that's a really nice way to solve these. So my solution is 3, negative 1, 2. And then you can check it to see that it works. Oh, I forgot to write my solution up here. Negative 2, 1. Okay, so that concludes the lesson for 6.5. Go to my math lab, do your exercise there, and I'll see you next time.